Okay. So like I said, logs are the inverse to exponential functions. All right. So the real foundation of what we're going to be doing is this slide right here. Okay. The inverse of an exponential function is a logarithmic function. Okay. On the left is exponential function. So the base, it's going to be a number or variable or something, but the base is the big number that the exponent is attached to. Okay. The exponent, or y, is the little number, right? The superscript, an exponent, and then the answer is x. Okay, we can write that in logarithmic form. Okay, then we write log. We like write log. Okay, then the base becomes our little b. That's a subscript. It's the base of our log. The x becomes what we're like finding the log of, and then the y, which was our exponent, becomes our new solution in a way. Okay, so this is something that I would encourage you to write down. It's going to show up on almost every slide that we're going to do today. All right, so if you haven't written this down, I would write it in your notebook. Okay, so let's look at these first two at the top. So write down the first two examples. So the log 416 equals 2. And all we're doing right now is switching forms. So right now they're both in logarithmic form, so we are going to write them in exponential form. So I'm going to use those highlight colors like I said. This is my b, this is the x, this is the y. So then what I'm going to do is I'm going to take my base, which is my green number, and we're going to make it big now. My orange number, my y, becomes my exponent, and then my pink number becomes my answer, which is 16. And then we ask ourselves, in this case, is that correct? Is 4 squared 16? Yep, we're good. All right, the next one. My base in this case is 9. My x is 3. My y is 1/2. So then the 9 becomes my big base. The 1/2 becomes my exponent. And then the 3 becomes my solution. Now this is where there's going to be two places in this lesson where we have like some little mini reviews. Okay, this is one of them. We have a fractional or a rational exponent, right? 9 to the 1/2. What does that mean? 9 to the power of 1/2. What's another way that we can write that? Yeah, it's a square root. Okay, so remember this. This is when we first talked about this year. X to the m over n equals the nth root of x to the m. Okay, so if I have 9 to the 1/2, okay, the half goes here, which just makes it a square root of 9 to the first. Now, typically with square roots and with the power of 1, we don't write those numbers in there. We wouldn't write the 2 or the 1. Okay, but we want to know that. Okay, so just remembering that a rational exponent, a fractional exponent, gets us into radical form. Okay, so that is correct. The square root of 9 is 3. Okay, so that's the first little mini example. Okay, now the next one we're going to write in logarithmic form. Okay, so we're going to use the same thing, the same little cheat sheet. I'm going to move it over here so we can see them. So in this case, my base is the big one, my orange, and my pink. So we want to write this in log form. So the first thing I do is write log. And then my base becomes my subscript of my log. So I put a 3 there. My 81 goes here. and then equals y, which is 4. So now we've turned the exponential form into logarithmic form. Okay, now we're going to do the next one. So there's my base, there's my y, and there is my x. So then the first step is to write log. My base is going to be 2 of what? 1/8 equals -3. Any questions on this slide here? How did we get, why did you blank? Okay. Let's try our next two. So let's do these two right here. And they're starting in log form, and then we're going to write them in exponential form. I'm going to give you some time. Write these down in your notes and then write them. Oh, no, sorry. This is evaluate. Excuse me. Sorry. It says evaluate. That's a pretty important thing here. Okay. So now we evaluate means like figure out what it is. So figure out what it equals, and we're not going to use our calculator. Okay. So without using a calculator. So what we have to do here is finish this thing out. So we have our base, right? We have our x. What are we missing? The y, right? So we're just going to put y right here. And that's what we're trying to figure out, is what is y equal to. Right? So to do this without using a calculator, we want to convert it to exponential form. Okay, so my base becomes 3. My exponent is what? Y equals, and then 27. Okay, so now this is where just knowing your multiplication facts can be really helpful. 3 times 3 is 9, and then times 3 again is 27. So that would mean how many times did we have to multiply 3 by itself? 3 times. So y in this case equals 3. Okay, the next one. We have our base, we have our x, but again, we're missing our y. So we're going to write the y in over here. Take a minute and write that into exponential form. This is where the second little built-in review is on this problem right here. Okay. The green becomes our base, so it's 5 to the power of y equals 1/5. So I see I've got a 5 and a 1/5. I need to take 5 to the power of something to get it to 1 over 5. So right now, the green one is 5 over 1, right? That's really what it is as a whole number, 5 over 1. So I need to reciprocate this. So how can I flip it? What would I do here, Carson? -1. Okay, so in this example, y equals -1. Okay, so that's our answer to this one. I'm going to slide over here to the right a little bit and just a little bit of a review here. So to rewrite this, it would be 5 to the -1st equals 1 over 5. Because that's really 5 to the 1st, right? Okay. If it's 5 to the -2nd, so squared, right? What the negative does is it reciprocates it, so it's going to put it over 1, or under 1, excuse me. And then what's 5 squared? 25. Okay. Now, if we have it as 1 over 5 to the -2nd. So now the negative exponent on the bottom. We have to reciprocate it. Okay. So now we're going to take it and put it on the top, which is going to be 25 over 1. Okay. These are some exponential things that we went over earlier in the year. It was part of our prerequisite chapter, but it's a little built-in review here. the function of rational exponents, which is what we did on the previous slide, when it's a fraction, okay, and then negative exponents and how they affect our problems. All right, let's do these two down here now. Remember, on both of these, we're missing the y. So we're going to put y there, y there. All right, the first thing we want to do is write this in exponential form. So my base is going to be 8 to the power of y equals, and then my pink, my x here, is all of this 8 squared. And like Carson was asking, I'm going to keep that together. And the reason why is now I can see that my base is the same on both numbers. So now I just need my exponents to match. So y equals 2. Okay. On the next one, my base is 2 to the power of y equals the square root of 2. This goes back to that little mini review we just did. If I want to get it to the square root of 2, well, my degree is 2. My exponent in here is 1. So that means that y is equal to 1/2. Okay. Any questions on those four? Oh, you guys are doing a really great job writing notes down and doing that. All right, next one. We're going to skip that. We're going to talk about other types of logs here. So we have common logs and natural logs. This at the top that we keep referring back to is still going to be a big piece of what we're doing here, okay? So common log, that means that the base is 10. Okay, and what that might look like is this. If we have, for example, log, let's just say log of 5. We'll just write it like that, log of 5. See how there is no number down here? Okay, what that means is that the base is 10. Okay, so what I like to kind of compare this to is if I wrote down radical 16, what number is right here? 2, right? You guys already know that the index of this is 2, right? You guys know that. Okay, and it's just something that over the years you've recognized that, hey, if there's not a number there, we know it's a square root, right? If I put a 3 where the red dot is, then you guys know it's a cube root or a fourth root or a fifth root, right? But if there's nothing there, you know that it's a square root. The same thing goes with logs. So if there's no number there for our base, we just know it's 10. Okay, so then it would be log 10 of 5. Okay, natural logs. The way that this one would work is it would be log e of 5. But we just don't write that. Okay, so what we would do is we would say ln of 5. But knowing that ln is the same as log e helps us change it from one form to the other. You're going to see why here in a minute. Okay, we got that? All right, so we're going to start out with these two on the top. They're the same as what we've been doing. The only difference is the one on the right is just rearranged. It has the base on the right. Okay, so base on the right, x on the left. Okay, the one on the left is in exponential or logarithmic form. So we're just rewriting them. So when it says find the inverse function, remember that logs are the inverse of exponential. Exponential are the inverse of logs. So we're going to just write it into the other form. So the one on the right is going to be x cubed equals 15. The one on the right, we're going to write log 7 of 49 equals 2. And right now we're not like solving these or anything. You're just writing the inverse, okay? We good with those two? All right, the next two. What we're going to recognize here is that on the left we have an e, right? Okay, so what I want you to do is do this the same exact way that we've been doing this, okay? So it's in exponential form right now. So if I were to highlight this, the e is my base, the exponent 2/5 is my y, and this is my x. Okay, we're going to write it and do it the exact same way. So I'm going to write log of e of 5x equals 2/5. But what did we say about that log e thing? We don't do that, right? So what are we going to write instead? ln. We're going to change this to ln of 5x equals 2/5. That's how we would write it. Right, what's missing on the next one? What don't we have up there? Yeah, we don't have a base. So then what do we know? Our base is 10. And if it really helps you, if you really want to, are you going to hurt anybody by writing a 10 in there? No, do it. If it helps you, do it. So then we're going to have 10. What's my exponent going to be? To the 4th equals what? 10,000. Just like that. Right, any questions on those examples there? Okay. Let's do these last two. The one on the left is pretty straightforward. Okay, not really anything new. It just has a decimal as the base. The one on the right does take a little bit of extra thought. The one on the right, if it helps you, this is actually y in the form that we have it in. One tip that I would give you on the second one is when we're trying to convert it back to exponential form, when you see the ln, I would cross that out and write log e. Because now I know that my base is going to be what? E. Right? So I'm kind of starting on the right, but it's going to be e to the x or y, depending on what letter you used, equals 5. The one on the left is going to be log then 0.28 of x equals 1/3. Any questions on those 6? Okay, now we can put these into our calculators. Okay, so I'm going to show you what that calculator looks like here. If you have a calculator like these, okay, the two buttons that we're talking about here are where's my pen? This one and this one. Okay, so log and then ln is your natural log. Okay, like don't overcomplicate this. If it says log, we're going to hit which button? The log button. Okay, so then you just close. Make sure you, after you hit it, you put in your number, and then you have to close your parentheses. So on your calculator, it's going to look like this: log 8, which is going to be equal to 0. We're going to go to the thousands place, so 0.903. Okay, how about log of 256? What do we get? 2.408. Log of 12. Yep. Okay, how about log of negative 3? It says error, right? Okay, put your calculators down. Let's think a little bit about why. Okay, first of all, what is the base of this log here? It'd be 10 because it's a common log. Okay, and then equals y. Okay, so then if we rewrite this, it's going to be 10, because that's my base, okay, to the power of y equals negative 3. Is that ever going to happen? Is 10 to the power of anything equal to negative 3? No, so we cannot do that, okay? We cannot do either of those. You cannot have negative log or natural log. All right, this is going to be your homework today. I'm going to hand this out. We are only doing these problems, okay? And then I'm crossing these off for today, okay?